Okay, so for this problem, we need to determine the force required at the flange to hold the nozzle in place. So we need to start by getting our area for both D1 and D2. We're going to find that in feet rather than inches because the rest of the problem deals in feet. So start now, A1 is equal to pi over 4 times 12 squared. That is equal to 0.785 feet squared. A2 equal to pi over 4, 8 over 12 squared is equal to 0.349 square feet. Now, our Q, our flow rate, is 15 cubic feet per second, as shown in the statement. From here, we can find our velocity, because we have A and Q. So V1 is equal to Q over A1, which is 15 over 0.785. This equals 19.108 feet per second. Now V2, same system, Q over A2 equals 15 over 0.349. This is equal to 42.980 feet per second. Alright, so from here we can use Bernoulli's equation to find pressure. Now we only need to find pressure at diameter 1, which would be P1, because at diameter 2 it's open to atmosphere, so the pressure is 0. So we can set up Bernoulli's equation. So starting P1 over the specific weight of water, which is 62.4, plus velocity 1 squared. Well, we'll just add in our velocities because we already know them. So 19.108 squared over 2 times gravity, which in British gravitational units is 32.2, plus Z1, which is going to be 0 because we don't have any change in height, equals P2 over 62.4. Now P2 is going to be 0, so we can cross that off. It's 0. Plus velocity 2. Velocity 2 is 42.980 feet per second. Sorry if you couldn't see that before. 42.980 squared over 2 times 32.2 plus Z2, which is also 0. So now we're left with one variable just to solve for. Let's solve that out. So P1 over 62.4 equals 19.108 squared over 64.4, which is equal to, sorry, that's not an equal, so that's a plus, 5.669. And then this side of the equation, 42.980 squared over 64.4 is equal to 28.680. So P1 is equal to 1,436.165 pounds squared per foot. Alright, so now we have our P1. We have all the variables we need to find our force. So let's draw a somewhat free body diagram here. So force at 1 here with our pressure at 1. F1 is pushing this way. F2 is also pushing this way, but there's no force at F2 because there's zero pressure, and force is pressure times area. So if our pressure is 0, we still have an area, but our force will be 0. So that's out of there. And then our force at the flange is pushing back this way. So F, we'll call that. All right, so we can outline our forces in the X. There's no forces in the Y. So forces in the X, that'll be F1 minus FF, since FF is trying to go back. Obviously, these equal out to 0, since there's no movement. All right. So to use our linear momentum formula to find force in the X, we will use that. So linear momentum, F of X equals m dot 1 times velocity 1 minus m dot 2 velocity 2. So we're going to have to switch some things around because velocity 2 is going the other way. So we will have negative m dot 1 plus velocity 2. So this is what we're going to end up with filling this out. To find m dot, we do density times area times velocity. Okay, so we are going to put all this together and simplify this so that we can get down into a simpler formula here for f of x. So f of x is equal to f1 minus ff. This is equal to negative density of water times area 1 times velocity 1 times velocity 1 again, plus density water, area 2, velocity 2 times velocity 2 again. All right, so we can simplify this out a little bit. F1 minus FF. A times V is Q, so we can put Q back in. So equals negative Q times velocity 1 plus density Q times velocity 2. All right, so we can simplify this again. We can take the Q's out and the P's out, or the density out, and what we will be left with is density times flow rate V1 minus V2 minus V1 equal to F1 minus FF. All right, before we can input all of our variables into this, there's one more that we need to find, and that is F1. So F1 is equal to A1 times P1. So F1 equal to area 1, 0.785 times P1, 1,436.165. So F1 is equal to 1,127.39. All right, so now we can finally put everything into here. We've got all our variables, our F1. We have we can find our density on our table right here. So density is 1.94. Our Q, 15 feet per second, cubic feet per second. Our velocity 1 and 2, 42.98 feet per second and 19.108 feet per second. So that should be all. And then we're solving for FF. So F1, 1,127.39 minus FF solve that, times 42.980 minus 19.108. Alright, solving that out, we get 0.94 times 15, 9.1 times 42.980 minus 19.108, 23.872. Multiplying those together, we get 649.675. Alright, solving out for force at the flange, we have 432.714 pounds of force that it requires to hold the nozzle in place. Alright, that is it.